We're going to get started right now. Are we good? Yeah. Testing the audio. Are we echoing? It's off. Yeah, testing. Continuing to test. Am I still getting it? Sorry, friend. You're testing some of the audio in the room.
No problem.
It's your problem. Turn one of the speakers if you thought they were seeing
Okay, testing, continuing to test to see if we have echo. Testing. Isn't there like a script that people say when they're testing? It's in Hollywood. That's what I need to see from Hollywood. Is like, what is the testing script when they're testing audio for movies and stuff? They have to have so many microphones. There's got to be a script, something fun they say. Maybe it is the script. That makes too much sense. This is what happens when you ask me to test audio. I just start rambling my innermost thoughts. They're usually not great. Oh my gosh. That's okay. I feel like there's a joke about like how many engineers does it take somewhere in here? And the answer is a handful. We love them. We love our engineers.
What is
From the script, because they have to like say hours of content and like to test a microphone, and it's got to get boring sometimes. And so there has to be like a script or like something funny they say to each other. And I just want to know what it is, and I'd be willing to read that book. Is what I'm telling an audio engineer in mind.
making sure this doesn't happen?
Yeah, the microphone and the speaker here are both.
Right now.
Oh, enough for him to pick up my background. Less background? Yeah.
Have them talk.
Francis, could you give us like an audio test, like just go ahead and say.
Testing. Hello. Testing 1, 2, 3. 4, 5, 6, 7, 8, 9, 10.
It's fine.
Hello.
And so the problem is
me.
Yeah.
It's me.
It's I.
What if I just spoke really loudly? Francis, can you hear me now?
Is there a way we can play this audio versus not for audio? When Allison talks, just turn it off, and he talks, turn it on. That makes sense?
Yeah, I can.
Yeah, so then we get into the actual have to use that. What if they just came here for a question? That's okay. We all we want to hear is friends. Yeah, we're separate.
Okay.
Let's do it.
Okay, let's-
I'll get up here and Ben and introduce what's about to happen. Yeah, we're just gonna let him tell you.
Okay, yeah.
And you can feed him to him. Feed him
Yeah.
questions, but primarily just let them talk. If you prep him on what's gonna happen, I'll prep the audience. Whenever he comes back, I'll let you prep them and then I'll. Okay. You just can't, you get to like let me know.
You could also feed me questions in the chat. Would that work?
When you're done
Yeah.
answering questions.
Can you also, can you hear me now?
I can hear you now, yeah.
Okay, so then yes, what I'm gonna do is I'll just say questions to you here. I talk pretty loud. There's about 3 tables who will hear me. And then the important part is we'll hear you. Everybody will hear you. So you're on the speaker. So everyone in the room will be able to hear you. Sam is introducing the crowd kind of to how it's gonna work.
And should I repeat the question?
You can, sure, do a conference style, but I don't want conference style answers. We want, we're in a bar in Indianapolis in the Midwest.
Okay.
Also, I find it interesting you count from 0 to 10 and not 10 to 0. I think that says something psychologically, but I don't know what. I'm gonna go ask somebody.
I don't
What does it
know.
mean if I count down or up? All right.
Allison, it is you whenever you're ready.
All right, Francis, you're on. So go ahead, introduce us to you and what you do and maybe how the book came to be.
All right, sounds good. So, hi, I'm Francis Su. I am a professor of mathematics at Harvard College, which is a small liberal arts college of science and engineering in Southern California. I've been teaching here for 27 years. I love my job. I love working with students. I love teaching, and I love doing research with undergraduates. I think can say a little bit about the book. Sorry, there's a mosquito here in the room somewhere, so I have to wave it off. A little bit about the book, how the book came to be. As you probably read in the intro, it was sort of the outgrowth of a speech I gave at the end of my term as president of the Mathematical Association of America. And one of the things that I wanted to do was to try to speak about the bigger questions around why we do mathematics. Many of these, the conversations people have around math, it happen because people have a very limited view of mathematics, and I wanted to broaden people's perspective. It also had come out of a journey of my own soul searching in trying to articulate why it was worthwhile to do math. I think I went through a period when I late in college when I began to question, like, what was the purpose? Why am I so attracted and drawn to this thing? But is it only a selfish desire? And was there a larger way of understanding? So that's part of the genesis of the book. Maybe I'll stop there so I don't babble.
Yeah. So I think that brings me to my next question. Did you write this for people who love math or people who hate math? Or maybe both?
I would say both. Yeah, and there were lots of audiences I was trying to reach. I was certainly trying to reach those who never see themselves, who never seen themselves as math people. I also wanted to speak to professional mathematicians and mathematics teachers because I thought that there was a place of mathematics that might challenge that crowd as well. And then I wanted to also speak to people who might not actually be interested in reading math, but they want to read a book. I mean, in many ways, I describe this book as a meditation on what it means to be a human being. And so it speaks to maybe some larger questions, larger desires that I think all of us have.
Absolutely. And I think that came across as in a lot of our discussion before you joined, were people feeling that way about the book. And so you talk about mathematics education. Why do you think it is so rigid and so non-exploratory?
Yeah, so one of the I think the issues around mathematics education is that, we often have a very cut and dried view of math. I think partly because when we think about how do you test whether somebody, you generally think of just giving them a set of math questions to answer. And one of the problems is that the way we test our students also shapes the way they think about the subject. So you can say, I can say all I want that math is really about a set of virtues, a set of, ways of being. Like, for instance, being persistent in problem solving is a virtue that's built by wrestling with a good math problem. But that's not often measured or assessed on exams, right? So you basically often just solve, 100 problems. They're all the same, and you're tested on whether a certain fraction you get right. But, part of the thing that I try to communicate in the book, but I certainly say this when I speak to math teachers, is we got to be doing more than just testing skills. We got to be sending the message, building, part of the point of a mathematics class is shaping the way that you think. In some ways, it's forming your character in certain ways, right? To be persistent in problem solving, to be creative, to find joy and beauty in this pursuit. These are all things that the great math education will build, but they're not often assessed on exams or the way we think. So that's one way I think we need to change what we assess. Change the way that we speak about what it means to have mathematical skills.
Well, in the book also about how we reward only certain aspects of mathematics. So we're rewarding, but we're not really rewarding ending and the exploration. So how can we re-incentivize people to see mathematics
as the journey, I guess, is part of the reward? Because you talk about it with some of your more advanced academic pursuits. The journey is also part of the learning, and that's also part of the output. That's part of the reward. How do we incentivize that in education?
Yeah, so when I think about the ways that all the things that I enjoy about mathematics as a professional mathematician, many of those things are not reflected in the way we teach math, especially at the K through 12 level. Right? Like, I collaborate with people a lot. I have a lot of enjoyment thinking about hard problems and sitting there wrestling with a hard problem for a very long time. And when you look at the kinds of things that you see in K through 12, what you see is basically kids are learning math in a very individualistic way, right? There isn't necessarily a lot of exploration and play. And they come to see math as just learning to be a human calculator, right? And the funny thing is, we don't need better human calculators. We have calculators, so we have to start teaching math like it's the 21st century, which means leaning in on some of the technological devices we have, and also understanding how they work. These are some of the virtues that are built when you begin to understand mathematics at a deep level. And so one of the ways that I try to change the way people think about math is to change the way people talk about it. So for instance, I don't like thinking about, sorry, there's the mosquito. No. Got it. Sorry about that. It's just been buzzing around.
Gotta add mosquito hunter to your CV.
Yeah. I'm not sure what I was saying.
Oh, inspiring people to change the way.
Oh yeah. So I like to say that anything a calculator can do really isn't the heart of mathematics, right? Like, if you're thinking about math as just calculation, then of course it's going to seem boring and dry and dull, right? But if you're thinking about math as innovation, as being creative, in problem solving, those are the kinds of things that actually can make kids find joy in math. And so I like to say that arithmetic is a math. Math is really about good thinking. It's about wanting to see the world in a different way and to find joy and inspiration in doing so.
Wow. And I love that. And I think that takes us into what has been a popular topic of conversation for our group, which is AI, machine learning, artificial intelligence. You even talk about it a little bit in the book about how AI is kind of hindered by the material we use to make it in the field of mathematics. How do you see AI growing into the field of mathematics, and specifically the role of AI for math learners? It almost seems like it's a substitute for learning, but it really shouldn't be.
Yeah, so here's one way to think about. I guess a lot to say about AI. On one hand, AI is a tool. It's just another tool like a computer or a calculator. It's maybe the next step in the evolution of technological devices that can help mankind or maybe hurt mankind. But all these things need to be weighed with some wisdom and some understanding. AI is it can do a lot of wonderful things. Just to give an example, I had a leak at my house that I didn't know about, had a huge bill, and so I decided to buy a water monitoring device. And it's just a simple device that attaches to the meter outside and detects the spinning of the dial. That's all it does. You don't even need a plumber to install it. But the amazing thing is it's using machine learning to tell you which devices are on at particular times just by the pattern of the water being turned on and off. Okay, and so it's basically using a form of artificial intelligence to help you distinguish, to help you tell whether it's the toilet leaking or whether it's the dishwasher. This is a very simple example. Of course, AI can be used in medicine as well to help us fight cancers, right? But there's also a lot of harm that could come if we don't think about these things wisely. And so I guess I'm not fearful of AI in the sense that I think it's something we just need to learn how to use well.
Yeah, no, that's a great answer and a great perspective. We've talked about AI a lot, and so it's
ever becoming a growing part of our just every.
We're talking about it in our everyday Google searches. It's kind of overwhelming, but when you have experts like you talk about it, it feels a little more comforting. So I want to talk about, you inspire the reader to learn. Way, but how can we unlearn our
negative associations and unlearn our negative approaches to a subject like mathematics that has, for many people, such a
history?
Yeah. So I think of mathematics as learning to think well. And there's, of course, lots of ways that you can learn to think well. And you might say, well, that's not necessarily mathematics, but I would say anytime you're learning to think well, you're doing a form of mathematics. And anytime you're learning to strategize, you're doing mathematics. Anytime you're playing, a game of strategy, that's an example where you have to think, what happens if I do this, then something else happens. That's learning to think in a logical way. That's mathematical thinking. Anytime you visualize, you have to use your brain to begin to see something, see patterns in visual information. That's thinking mathematically. So there's lots of different ways to be mathematical. And once we begin to see that, then I hope we'll step away from just seeing math as this one-dimensional, I'm learning how to be a calculator, and a speedy one at that. If you take a look at anybody who does math for a living, speed isn't even a thing, right? Like nobody, nobody questions whether I can calculate some quantity, do some math problem quickly. And in fact, there's a recent article that came out recently where some scientists did some studies on good mathematical thinkers and average thinkers, and it turns out good thinkers actually spend longer thinking about some problems, which, when you think about it, makes sense, because if good thinkers actually know that to understand something, you want to spend time on it to understand it. So I'd like us to get away from saying math is a one-dimensional thing that's only about arithmetic or calculation, and see it as something that's multi-dimensional. It impacts every aspect of your life.
Yeah, absolutely. I think a lot of people in the room, as we've reflected on this, have started to not only view mathematics differently, but view our daily interactions with mathematics differently. And I feel like over time it will build the confidence to call ourselves maybe math. I don't know if I call myself a math lover. I'll call myself a math
explorer.
An explorer. And I love that term, explorer. How can we encourage people around us from childhood age to adult to become math explorers?
Yeah, well, you have to start in the home. I mean, it's certainly helpful if it starts in the home. And one of the things that I like to remind people is that, or tell people if they didn't know, is that like if your relationship to mathematics actually matters a lot for the people around you in your life, especially your kids. Studies show that parents with math anxiety actually pass that anxiety on to their kids. And, in some sense, what that means is that math anxiety is probably better if you don't help your kids with their homework, and then if you do. But it also points to the importance for us to begin to shape and change the way we talk about math and change the way we think about who does mathematics, because all of us are, in some ways, deeply mathematical thinkers. And just to give you an example, I have a 3-year-old son who is, learning lots of words and things like that. And, the other day, so the whole time my wife and I had been married, we never unpacked our TV. Okay, we're not TV watchers. We watch everything on the computer now, anyways, right? Our phones. But anyways, we had some friends over, and they were coming over. And said, "Okay, well, let's unpack the TV." And so our 2-year-old at the time, he looked at the thing, and he'd never seen anything so glorious. He was just like mesmerized by this thing. And so the next day he says to us, "Shall we turn on Big Phone?" And we were like, first of all, we said, like, "What do you mean, Big Phone? What?" And then he pulled us over to the TV and was like, yes, Big Phone. Now, what did our son do? What was he doing? I claim he was doing something very mathematical. He was looking at two things that could potentially, that live in different categories, at least for me. Like I don't think of the TV as a phone. And he was putting them together, right? That's abstraction. Right? That's showing that all of us have this ability, that inherent ability to be able to look at two things that are dissimilar and think about how they're similar. And that's all. And that's really what abstraction is.
He sounds like a budding mathematician.
But every kid does that, right? So all of us, in some sense, are little mini mathematicians.
I feel like after this book, I will be nurturing my inner mathematician and appreciating the math that I do on a daily basis. You do a lot more than you think. I mean, every day. I want to ask you about the book. I want to ask you what was your favorite and maybe, I don't want to say least favorite, but I'll say hardest chapter to write.
That's a good question. The question was what chapters stand out to me as particularly hard to write. That's a hard question. Well, and part of it is, so I originally wrote this speech, and the speech had some had a structure that was similar to the book, but it had 5 themes in it rather than 12 or 13 chapters that the book has. And, I thought, the speech talked about beauty. And so I thought that would probably be an easy chapter to write. And I found it actually was a lot harder to write than I thought, because I hadn't really said that much about beauty in the speech. And then I realized that, there's a lot that one could say, and I didn't want to just tread ground that people have treaded before. Like most of the writing around mathematical beauty has been sort of a clinical writing, which is sort of saying, analyzing the kinds of properties that beauty has, mathematical beauty has. And I decided at some point to lean into the emotional experience of beauty. And so that's why I wrote the chapter that I did, talking about the feelings that people have when they experience beauty, because that's maybe similar to the kinds of feelings that other people have in doing other things in their lives. So I talk about, the thrill of an aha moment is like seeing the end of a mystery movie, right, where everything gets explained. That's a feeling, right? Many people have really deep, almost spiritual feelings around mathematics because it awakens in us certain a deep awe or a deep reverence or deep appreciation. And so, anyways, that was one chapter that I thought was challenging. The last chapter, the chapter on love, was actually also challenging. Because, when you see the title Love, you think, oh, this is a chapter about loving math. When in reality, it's really not a book of, it's not even a book about loving math. It's more a book about how you love people through and because of mathematics. And so, I initially wrote the last chapter, and my editor said to me, basically, this isn't going to cut it. And I was like, what do you mean? And he said, Francis, you're at your best when you tell personal stories. And so I took that advice, and I basically, leaned in and returned to a theme that I picked up in the first chapter, which was my failure, times that I've been a failure in mathematics in some sense, and how that enabled me to empathize in some sense with the experience of many of you all who, all of us have had a challenging experience.
Recording in progress.
That's fascinating that those were, I think those were the two chapters that maybe resonated with me the most, especially love. That was just a beautiful chapter. Just what a beautiful way to round out that book. Your editor was wrong. Or you rewrote it to be.
I rewrote it. You didn't see the other chapter, which was not as good, I have to say. Not as good.
Okay. Well, it was a beautiful way to round out the book. In my opinion, obviously. But I want to ask the question actually that came to us from the audience. Do you have a favorite math puzzle that didn't make it into the book?
Favorite math puzzle? Well, there are lots. There were lots of math puzzles I guess the question is, what could I do in this contract? A math puzzle. I could show you a mathematical card trick. How's that? Would y'all be happy with that? Okay, so here's a deck of cards that I have here. Which, can everybody see this deck? Looks like a normal deck, yes? Okay, so I'm just going to pick a volunteer from the audience just to make sure I didn't do anything funny. One of you is going to shuffle the deck. Well, okay. We may not be able to really physically do this, but let's just pretend, eh? So, do you have a volunteer? I want to be you.
You want to come on?
No, it's fine. You got somebody? Okay, so it's Allison, right? Okay, so Allison, just pretend I'm giving you this deck, okay? And you're going to take it, and you got to give it a riffle shuffle. Okay, just pretend like you have it. Okay, and now after you're done riffle shuffling it, going to so what's a riffle shuffle? It looks just like what you're doing. That's right. And in fact, maybe I'll show people what I'm doing here on top of my electric bill, which is sitting on my table. And you're going to push it together like that. Yes, that's a riffle shuffle. Anyone with me? Okay, go ahead and hand back the deck. Go ahead, hand it back to me. Yep. Thank you very much. Okay, great. Now that Allison has shuffled the deck, would you agree there's no possible way I could know the ordering of this deck of cards? Okay. So then you might believe I was born with a special ability. And the special ability is that I can feel the colors of the cards with my fingertips. You're like, what? No, not really. Actually, I could not tell you whether this card is red or black. I have no idea. It actually turns out to be black, yes. But I claim I can pick out pairs of cards that are opposite colors. So I'm going to put this behind my back so you can see. I'm not doing anything funny. There's nothing special except a deck behind my back, okay? So I'll pick out two cards that are opposite colors, red and black. Yeah, you shouldn't be too impressed at this point because there was a 1 in 2 chance approximately that I would get that opposite colors, okay? But I'll keep doing it. So now I'll do it again, red and black. Red and black. Red and black. Okay, and of course the chance that I'm doing that 4 times in a row is actually 1 in 16, and now it's 1 in 32 when I've done that. It's 1 in 64 when I've done that. And it's 1 in 128 when I've done that. And at some point, people are going to be impressed and maybe clap. I don't know. People are going to clap? Yeah, okay. Thank you. Now, this is kind of a neat, nifty trick. I'm really doing nothing special. There's no special deck behind my back. And now you might have a conjecture. You might have a wondering around what's going on because you don't believe I actually have this ability, yes? So take a moment, just a minute at your tables to take a guess as to what's going on. And maybe there'll be some ideas from the audience. You can talk about it with your neighbor. Some of you are probably wondering, what's the deck really look like behind the scenes? And here's the deck. And yet, I can still do this. Red, black. Red, black. Red, black. Keep going. All right, any ideas from the audience? So the amazing thing about this trick is that it's actually a mathematical card trick. It's guaranteed to work as long as you figure out you know what you're doing. But I think that what's more amazing about this trick is that it's beautiful when you see what's going on. When you understand, when you see what's happening, you'll be like, whoa. So do you all want to see how to do this trick? Yes? Okay. So you have to just promise me you're not going to tell another soul how to do this trick, okay? All right. I won't hold you to that promise. It's okay. So before the trick starts, you have to stack the deck in some special way. And the surprise is that even after your volunteer, Allison, shuffles the deck, there's still going to be some order in the deck. So a deck actually, a riffle shuffle doesn't really mix the deck that well. You need to shuffle the deck many times before it's well mixed, okay? And so here's the thing. Here's what you do beforehand. So before the trick starts, you have to have a deck that you've already ordered in a special way. And I'll just take a few cards here just to demonstrate. So you have to order the deck so that the colors are alternating So do you see that? This is perfectly alternating. But when you show people, when you fan it out and you show people at the beginning, they're not going to notice that because the cards are clumped. Yes? So that's what you do to try to throw people off. You say, this is a normal deck. Nothing special about it. But just to be sure, we're going to get a volunteer. Allison. Allison, would you give the deck a riffle shuffle? Now, the second thing you have to remember about this trick is that when you give your volunteer the deck, you have to cut the deck for them. Okay? So before I give you the cards, I'm going to cut it for you. Are you with me? And the only thing you have to remember is you have to cut it so that the bottom halves are different colors. Okay? And then I hand that over to Allison. Now, Allison's going to shuffle this just by dropping cards, and she might be a really bad shuffler and just drop lots of cards from the same side. So there's no way, I can control what she's going to do, yes? So does everyone agree that the deck, even though it was alternating before, may not be alternating anymore after Allison drops the cards? Yes? But watch what happens. So I'm Allison now. What's Allison going to do? She's going to drop a card. And do I know which side is going to fall? No, it's random, yes? So which card is going to drop, red or black? Everyone say, I don't know. I don't know. Okay, good. Well, maybe it's black. But if Allison drops the black card, what's the next card have to be, no matter which side it falls from? Yeah, even if it falls from the same side. Right? Do you see that? Why does it have to, the next card have to be red? Because the deck was alternating, yes? So under the black card, there's going to be a red card, and even if Allison's a lousy shuffler, which we all know she is, we're going to drop, it's going to fall in a red-black pair. Are you with me? And now, what's the next card going to be? Say, I don't know. I don't know. We have no idea which card that's going to be, but suppose this time it's red. If it's red, what's the next card have to be? Black. It has to be black no matter what. And so once again, you get a red-black pair. Now, what's going to happen is she's going to drop a lot of cards one by one. And it could all just come from the same side all the time because she's a lousy shuffler, right? Who knows what happens? But no matter what happens, when you're done, the deck is no longer going to be perfectly alternating, is it? Right? In fact, it's not anymore, is it? Yes? But it will be in red-black or black-red pairs. And so all you're doing is something very easy. You're just picking pairs of cards off the top, and they'll always be black-red or red-black pairs. Which is kind of nifty, right? And so maybe something to take away from this is part of the beauty of the trick is that it demonstrates the power of mathematical thinking, right? That you're able to see patterns in something you thought was random. That's one little surprise. Another little surprise is the aha moment that many of you had when you realized that no matter what Allison does, the cards are going to come off in opposite colored pairs every time. And then, of course, there's a deeper questions you can ask. You can say, well, why did that trick, where did that principle come from? And it turns out there's a whole set of card tricks that are based on that principle. You can look it up. There's something called the Gilbreth principle, which allows you to do even more sophisticated kinds of card tricks. And so, that illustrates something I really love about math, which is you learn to see the world a different way, and you begin to appreciate some of those things that you see. And you learn how to be creative with it, right? I can now go and invent other card tricks once I understand the mathematics behind it. How did I do? How was that?
The room went silent, jaws on the floor. The room is clapping, and notes were taken. I will have you know, notes were taken on that card trick.
There's really no evidence that I spoiled a trick for all of you. But wasn't that joyful? Wasn't that Amazing. It's not my trick. I mean, I learned that from a book by Martin Gardner.
All right, so Francis Sue, the author, Francis Sue, the magician, Francis Sue, the professor, and I mean, I don't know. None of us were expecting that. Like literally, the room, we all were just looking at each other, jaws on the floor. That was so, but that like so embodies the meaning of the book and like the power of this book and really of you as a mathematician, as a professor, as an educator, and as I call it, I feel like you're an ambassador. You are the ambassador to mathematics. Maybe not the ambassador, but I feel like throughout your book, you encourage us all to become ambassadors to mathematics. And I think that's what's so beautiful about it. And that's why we all love it so much. Unfortunately, I will say we are having some pretty terrible technical difficulties. So unfortunately, I think we're going to have to cut our time with you short, which I'm so sorry. But I just want to thank you for your time. I want to thank you for showing us some magic tricks, card tricks. That is so cool. And I really want to thank you most of all for inspiring not only me, but everybody in the room to not only embrace our little inner mathematician, but to encourage those around us to think more positively about mathematics and encourage each other, because that's all we have at the end of the day. So I just want to thank you so much. You're wonderful, wonderful author. I will direct everyone to your website because you have some great resources there, some cool blogs. And I was gonna ask you what your favorite subject of math is, but I'm not gonna ask you to pick a favorite child. Or maybe you will. I'd like you to say one final goodbye to our crowd, and maybe you could tell them what your favorite subject of math is, what your favorite type of math is. But I don't want to make you pick.
Yeah. Thank you very much for having me. I guess I'll say, just to answer the question, my favorite area of math is something known as topology, which is the study of shape, study of how things connect to one another, and it's a beautiful area of mathematics that has all sorts of interesting consequences in the world, such as what's the shape of the universe? There's an interesting question. That's in some ways a topology question. But whatever. I hope you have a great evening, and thanks for entertaining me.
No, thank you, Francis. Big claps in the crowd. Thank you.
Okay, I ended it for all. Oh, yeah. Sure. Yeah.
Allison, your mic's hot.
All right. So first off, thank you guys for sticking with us. Not only was his book inspiring, just listening to him talk for 30 minutes, I mean, what an inspiring person. And so I want to leave you with one last turn and talk. And I want to talk about the book. I want to talk about what aspect of the book will you take with you? Maybe it's a chapter. You know, he talked about, the chapters on beauty and love were his hardest to write. And they caused him to reflect the most eternally. Maybe it's an aspect of, self-love and almost self-forgiveness that the book asks you to bring as you move forward in your math journey. And I think that would be my answer for this turn and talk. But what aspect of this book are you going to take with you? What lesson from this book, what feeling from this book are you going to take with you? I'll give you about 5 minutes to share with your table. And if any of you are brave enough, you can share with the group. Bye, live stream. Love you. I love you, live stream. And for the live stream viewers, next month, we will be discussing Dr. Dr. Mutter's Marvels, which, if you don't know, is a museum in Pennsylvania full of medical oddities. And this book was written in Well, it was written a few years ago. And so the book talks about Dr. Mutter. It talks about the collection that he amassed, kind of his life, why he became interested in medical oddities, why he became interested in collecting them. And it talks about kind of that journey, and it talks a little bit about the medical oddities. But we will be talking with members of the Indiana State Medical Museum. So we're going to get to talk about kind of the ethics of, medical even calling the nomenclature of medical oddities. We're going to talk about collecting them and profiting off of them in a museum. And if you are interested, there is I think it's a New York Times article talking about current controversies that the Dr. Mutter Museum is in right now, as not everyone agrees that profiting off of hundreds of years of human anatomy is morally or ethically correct, and some people don't feel that way. Some people feel very connected to the museum and feel that it does a service and good that is worth the medical or maybe ethical concerns. So we will have a certainly heated and spirited discussion next month, and it'll be on Halloween. So join us on Halloween. Bring your favorite beverage or bring your favorite candies. I know I'll be bringing some if you come join us at Ash and Elm. And let's talk about it. Anyway, see you next month, and toodles, toodoo.